Hello, this is Ethan Hershaft.
I'm Kai Bryant.
I'm Brandon Novak.
I'm Tyler Dietz.
And I'm Silas McIntosh.
And we are Team Stow-Range.
Electric scooters are becoming more and more popular each and every day due to their ease of transportation, their convenience, their affordability, and sustainability. But one major issue still lies within all electric scooters, and that's range. Most electric scooters only can hold about 10 to 20 miles per charge, which limits the amount of distance you can take your electric scooter for daily commutes, long travel distances, picking up groceries, or whatnot. Electric scooters also lack storage capacity, so you can't bring a lot of storage with you. Due to these limitations, users are forced to rely on the internal battery that belongs with their scooter. There's no way to extend the range with an external battery. Our team's goal is to design a product as universal as possible that can fit as many different manufacturer scooters to help extend range. But our team must work with the NIU KQI 100F model scooter to extend the range of that particular model. A goal of our project is to make it so users can upgrade their scooter with our product instead of upgrading to the higher end next model scooter. Some functionalities that our scooter should have is favoring battery capacity, user functionality, being able to switch batteries, and it should also be very durable, have a long lifespan, and very safe for the rider. The overall goal is for us to create a commercialized product that consumers can use and solve all these problems. And Team Stow-Range has come up with a solution for all of these problems. To address the issues of limited battery power and range and limited storage capacity, our solution is an external trailer that mounts to the scooter with an external battery pack. This is going to consist of better storage capacity, overall better user functionality, and more range coming out of your scooter. This design should be modular, able to be used on any manufacturer's scooter, and scalable for real-world use in the future. Our range extension system includes a couple key factors to help our system work, such as a 13S3P lithium-ion battery pack with 48 volts to help match the original 48-volt batteries that comes on the internal scooter. It'll also consist of a centralized BMS to help control the charging and use of our external battery. Our system will also have a trailer storage unit to store the external battery and other storage needs. A centralized BMS or battery management system was chosen for our project due to its low cost, ease of use, and high reliability, which is very important for daily use of our product.
Our main system requirement is to increase the range of our scooter by at least 50%. To do this, we want our system to run at 48 volts nominal and for our storage and battery to be less than 45 pounds. Our main system can be divided into two subsystems, that being the trailer and the electrical architecture. Our goal with the trailer was an addition that can match the quality of materials that the original scooter itself was made of. With this in mind, we want our trailer to be made of a durable metal such as steel, and we also want to include shock absorption tires and a plastic-based cover to protect our cargo. For user convenience, we want an easy attach and release system for our trailer. We want to include reflectors on the back for user safety, and for the trailer to have good airflow to reduce drag while moving. We made a CAD model to show what our ideal trailer would look like for our system. Our electrical system was designed to safely integrate our external battery with the scooter's main internal battery. Some key safety regulations is to have matching voltages between the two batteries to prevent overheating and overcurrent. In order to run our battery, we needed to decide on a BMS system that can safely regulate its charge. Using weighted rated tables, we came to the conclusion that a centralized BMS system would work best. Additional safety standards such as UL 2272 were also considered in order to ensure our system can handle real-world environments and situations.
To evaluate performance, we conducted range testing under controlled conditions. We went to a 2.6 mile loop called Lake Baldwin, and that's where we conducted all our range tests. The first range test, which we did with the OEM battery, resulted in a range of 9 miles, which is a 7.4 mile difference between the advertised and the range that we got in our range test. With the OEM battery and our external battery, a 13S3P system, we were able to get 32 miles with just the OEM battery and our external battery. A rider weight of approximately 200 pounds and an average speed of 14 miles an hour was used to conduct this range test. Data was collected using the new proprietary app as well as the Strava app on the iPhone to be able to compare data between the two. Some things that went wrong during our testing included the motor overheating as well as a tire blowout. So the reason why the motor overheated, we think, is because carrying too much weight behind the scooter, which is where the motor is housed. We had the trailer as well as the rider weight, and the tire blowout was also due to the motor overheating due to too much heat generated. We also conducted FMEA and ANSYS analysis for our testing. So ANSYS was used for structural and transient analysis of proper placement of the battery on the trailer. We also used structural analysis to be able to simulate bumps in the road to properly understand what would happen to the battery. Different failure modes were conducted through FMEA to see what could go wrong before physical testing of the scooter. Some of the things that we found that could go wrong included the battery, the trailer, electronics, and storage system. So as far as the battery, nickel plating could come off of the physical cell itself, and we could get an improper voltage reading. As far as the electronics, many things could go wrong, such as loose connections, improper wiring, or water ingress. With the trailer and storage subsystems, things such as unsecured weight or loose bolts could affect our testing.
To understand and analyze our scooter's overall energy efficiency, we used watt hours per mile. It was 243 watt hours, and we went a total of 9.4 miles, which broke down to about 25.9 watt hours per mile. Now, this was instrumental for the scooter because it gave us a baseline of how much we needed to extend the performance, how much we could extend the performance of our scooter. We wanted to use solar because we found out it could add as much as 50.6 thousand watt hours, and it just wasn't feasible because it just didn't charge the batteries enough practically in real time. And we also wanted to do additional regenerative braking, and we also noticed that that really wasn't feasible or practical because per trip it would have only added at best a half a mile. We just stuck with an extra battery, and it tremendously increased the scooter's potential.
It's time to reflect. While this project has seen a lot of success, there are some future changes that our team would make. The first change would be to create our own trailer. Originally, our team believed that at the start of the semester that there would not be a sufficient amount of time to build both a custom trailer and a custom battery. Towards the end of the project's timeline, we encountered issues attaching the trailer to the scooter, which would have been alleviated if we just built our own trailer. Another change we made is to do more preliminary electrical testing. After our team added ideal diodes and fuses to the circuitry for additional safety, the electrical current was not able to flow properly and the range was significantly reduced. If our team had done more thorough testing before installation, this could have saved us a lot of time. For future developments, we would like to increase the scooter's capabilities by having it be able to be installed on a multiple range of scooters. Currently, it is quite custom to our specific model, and it takes quite a long time to install. Furthermore, we would like to improve the weight distribution to both increase the range and allow more users to be able to ride the scooter. Overall, this project expands scooters into simple travel devices into reliable, everyday transportation solutions.
Thank you for watching.